Welcome, everyone. My name is James Mancini, and I'm one of the original founders of Netreo. Today, we're going to be talking about some of the key ways that we found to extend monitoring of imaging modalities and PACS environments in healthcare IT. All of the attendees are muted, so if you think of any questions during the presentation, please make sure to enter them into the questions section of the GoToWebinar interface, and we'll be sure to get those answered for you. Having successfully deployed our solution in some of the nation's largest healthcare environments, we've noticed a few common challenges when it comes to monitoring modalities and PACS environments. And many of you will probably be able to relate to some or all of these. So we're going to address solutions to each of them in turn. One of the most common challenges we hear customers talk about is that IT needs to monitor the modalities, but isn't given access. So typically the actual maintenance of the modalities are outsourced to the service provider or to another third party, and they're reluctant or completely unwilling to share any of that access. Yet the on-premise IT staff or the command center is still responsible for making sure they're working and talking across the network. So we need some way to confirm that the modalities are working and not have any issues, like, for example, wasting bandwidth or performance within compressed transfers or storing files locally or getting errors when they try to store files. Another really common issue we hear customers mention is that they get way too many false alarms. So inbox, phone, Slack are all exploding with alerts. And this is especially a problem after hours, where often the local staff is going to be turning off equipment even after being repeatedly told not to do that, but it generates alerts that waste knock resources and engineering time. However, we do need to be aware of unusual behavior or performance problems. So we can't turn monitoring or alerting off completely. We need a solution that's going to tell us about the important problems while ignoring things that aren't really an issue. The third common challenge we hear is that there isn't a big picture view of what's going on with the applications or the environment. So this makes it really hard to see what impact a particular server problem may or may not be having on the application. And the problem is confounded by the fact that the documentation is often or maybe even usually out of date. And this wastes still more troubleshooting time as we're troubleshooting symptoms instead of homing in on the root cause. Ultimately, that's going to cost us money in the form of wasted engineering time and extended outages and possibly even missed procedures. So how do we go about monitoring these systems if the modalities aren't going to give us access? The approach that we take is to monitor at multiple layers. So this gives us the ability to not only detect failures before the providers or users notice them, but it also allows us to isolate the cause of failures and to differentiate between a server running out of storage or an imaging system getting sluggish due to poor PACS response or a server crash. So we can focus our resources on the actual root cause and resolve the issue as fast as possible. In the case of modalities, the way we do that is we monitor their availability and connectivity via DICOM to make sure that they're ready and able to perform their function. But we also want to watch their traffic across the network so we can spot unusual activity or possible problems like a sudden drop in traffic that might indicate an issue or transmitting uncompressed data. We can also do things like monitor the work list entries to make sure things aren't getting backed up and check for local file storage, which can indicate a problem reaching the image storage resources. But we also need to watch the PAC side of the equation. So naturally, we're going to monitor the overall system health, things like CPU, memory usage, storage space, IO rates, latency, all of the basics that we would monitor for any server. So we can know when the problem is there and it's impacting the modalities. But we also want to watch the CPU usage and memory usage and status of the DICOM processes themselves. So we can spot any unusual activity, drop-offs, runaway processes, or when the service is having software issues. We also want to watch these transactions themselves. So by using synthetic DICOM transactions to measure availability and transaction latency, we can spot problems that might not show up from just watching the CPU, for example. We can also watch the user interface by using synthetic web transactions to make sure that it's responding properly and in a timely fashion, so we can keep an eye on the user experience and then integrate all of that data into a single dashboard. We also want to watch what's happening between the devices. So we've integrated the monitoring of things like NetFlow, QoS, and VRF traffic into the way that we watch healthcare traffic. So we can spot common problems like QoS misconfigurations where we might be streaming images into the wrong queue. It also allows us to find things like traffic that's been misrouted, misclassified, or sent across the wrong VRF. And we can use that data to spot congestion or queuing drops that shouldn't be happening. So that gives us a great way to identify performance issues and get them fixed quickly and efficiently. It also lets us get alerts when something is behaving abnormally using anomaly detection, which we'll talk more about in a little bit. Now, to address the second big issue, we need to get the alerts under control. So there's several technologies that we use to do this, but the first step is one of design. As a rule, we always recommend reserving alerts for actionable items only. So if you're not going to react to a notification when it comes in, you really shouldn't be alerting on it at all. For example, if you're getting alerts when the PACS drive reaches 90% utilization, but you're ignoring it because it's not urgent yet, two things are going to happen. Sooner or later, you're going to get a server failure because you forgot to circle back on that alert before the drive filled up. And second, you're conditioning yourself and your teams to ignore alerts, and someone someday will inevitably ignore the wrong one, and you're going to have a major problem on your hands. Instead, the approach we recommend is to use reports. So every morning, for example, I can get a list of servers that have the lowest free drive space. And I know if I deal with the top entries on that list, I get to sleep through the night. It can also help with things like capacity planning and creates a long-term archive of performance over time, so I can really get a picture of how things are changing over time and when I might need to add capacity or when I might need to make other changes. But to ensure success with this approach, I need to make sure that that all of those reports are automated, that they're scheduled, so nothing ever gets missed. Um, that way, as new devices are brought online, for example, they can be added into the appropriate reports without any manual intervention. And I'm not having to rely on some poor soul to remember to run the reports and email them out every single day. Another easy way to reduce over alerting is to take advantage of built-in technologies to leverage our tools. So I can use things like root cause detection that's built into the platform to drastically reduce the number of alerts that are generated during a major incident. That's going to reduce distractions to the team and avoid unneeded troubleshooting time, which is going to lead to a faster mean time to repair. So by configuring the topology into the tools or letting the tool discover it, including things like application dependencies, the tool can determine that the reason, for example, that all the modalities at a particular site suddenly started storing image locally was that the PACS server that they were supposed to be talking to got too slow and started backing up and not responding. So instead of sending out notifications for every single device separately, I can instead get a single alert that points me right to the cause of the problem. So if a WAN router goes down, for example, all of the devices at a particular site suddenly go unreachable, I can consolidate that into a single alarm that simply says the problem is the WAN router is not reachable, and not have to deal with, sorting through 50 alerts in the inbox to try to figure out which one happened first or what the root cause of those problems is. Another key technology that we want to be able to leverage is integrated event correlation. So this is really the foundation that allows for complex incident logic. For example, I can use event correlation rules to do things like preventing alerts from going out outside of working hours for a particular site or a device or a location. I can also use it to do things like to suppress alerts that are coming from a single system that's part of a cluster unless the cluster functionality itself is impacted. So this is really useful in the case of large scale clusters where a single cluster member failure might get routed to the hardware team, but cluster functionality failures need to go through the major incident response process. It can also do things like allow for automatic event validation before I send out those alerts. So for example, does the web application still work locally but is only failing from one remote site? I might want to handle or prioritize that incident differently than a total application failure, for example. Now, one of the key technologies that we use to simplify all this complex monitoring and cut the alerts down while still staying aware of what's going on is our anomaly detection technology. So since we're constantly logging performance telemetry on all the different monitored devices and applications, including metrics like the number of log messages received, CPU and memory usage of each process running on a system, we can automatically build a baseline behavior model using all of that data. And we store an extensive amount of historical data, much more than most other systems do. For most of the variables that we're storing, we have at least 100 days of the highest resolution data. So we can build a very complex baseline over time so that we can look for deviations from usual behavior. So we can compare what's happening now with what's normal for this time of day, this day of week, or even the hour by hour breakdown. And we can set the sensitivity of that detection depending on what the tolerance of the application is and the environment and what the usual range of that statistic is. So we can fine tune this process. That information can then be used to detect when something out of the ordinary is happening, and we can flag that as an anomaly that can generate alerts or reports. So this allows us to find things that we may not have expected. As an example, one of our customers discovered an issue because normally at 10 a.m. on a Wednesday, the PACS server was running at 75%. Suddenly this day it was running at 15%. And it turns out that a software update that got pushed to several devices was causing them to send images to the wrong system. But a change like that, a sudden drop in usage, is the kind of unusual behavior that will generally never trigger a static threshold. But in this case, it revealed a problem through the anomaly detection long before the users really noticed what was going on and detected that there was a problem with it. Another key method that we use to reduce alerts is the ability to tie the working hours for a particular site or location into the monitoring platform itself. So this allows us to automatically create things like maintenance windows so we can suppress alerts for systems that aren't supposed to be in use anyway. It can also do things like normalize uptime reporting so after hours outages aren't counted against the SLAs. And we also provide a distinctive dashboard screen for sites that are outside of working hours. So the NOC knows not to spend any time troubleshooting them should an alert slip through or should they notice something going on, but we still have access to all the historical and real-time data. It's just clearly flagged as being outside normal working hours for that location. So this can save a lot of wasted troubleshooting time and knock effort, and that translates directly into money saved. Knock time can be spent focused on real issues instead of troubleshooting a site where somebody powered off an MRI machine where they shouldn't have. But that really allows us to run a lot leaner and more efficiently, and that contributes to our ultimate ROI. The final key is really to be able to get a big picture view that we're after. See, even if we're already monitoring all the different devices in the environment, it isn't always obvious what kind of impact an outage is having. So for example, if we get an alert saying a particular database server is down, that's certainly useful and that's something we need to troubleshoot. But what does it really mean to the applications? So is it causing a slowdown? Is it causing a problem with the modalities? Are users impacted? What other applications are related to that particular system? And is anything affecting the users by it being down? The same thing with a cluster member failing, for example. If that's causing my application a serious impact, I'm going to prioritize that very differently than if everything is still working normally and I still have redundancy left. So I shouldn't have to rely on Magic Bob, the one engineer in the whole organization who happens to know which servers do what, to find that information out. That kind of tribal knowledge is not an effective way, to really run a command center or to troubleshoot problems. And if I have to wait for one particular individual who happens to have that knowledge, it can really slow things down. So it really needs to be immediately obvious to everyone in the command center and in the downstream value stream exactly what impact a particular outage is having and what's being affected by it. I also need to be able to see that from other kinds of deeply embedded systems. So for example, if the SAN loses a drive, that's not going to bring my application down. But what if it was the only solid state cache drive in that particular array and my application is now getting sluggish for the users? That's information I want to be able to know right away and see in my interface rather than waiting for the users to complain and then taking a while to track down what the cause is, because a whole different team is looking at that particular issue, and the folks who are getting the calls from the users in the knock aren't aware that storage is working on a problem or that they had a drive go down, and there's very little communication within the system. I need to be able to see that in a central global dashboard. So I need to be able to see that in a way that's easy to understand and communicate between the teams. So our approach here is to take all of this device level monitoring, all of the application level monitoring, all of the synthetic transactions and benchmarks that we're running all the time, and integrate all of that data into a single, easy to understand view. So we can immediately assess the impact of an outage and see what else might be affected, a true business level view. This lets us see the application flows across the different areas of responsibility and know at a glance what their status is. It also becomes dynamic documentation. So this actually helps me to orient new team members, show them how things work, and helps them understand the impact and scope of outages so they know how to react when a particular problem is going on. As a result, this also helps me get to the root cause of the problem faster and reduces my time to repair. And those are going to have an immediate and measurable impact on my IT spend. Once we have all these views, we need to make sure we're sharing them. So by making the monitoring data available to everyone in the value stream, everyone's going to have one common view of reality, a single source of truth. That's going to aid in communications. And it's also going to demonstrate transparency, which enhances trust. So a key to making this successful is to make it easy and quick to access the information so individual teams don't feel like they need to have their own separate monitoring, which can create a lot of alert noise and redundant effort, as well as creating admin support and maintenance spend issues. If the audience is non-technical, and there are always non-technical people we need to keep in the loop, don't hesitate to simplify or abstract the data into easier to understand formats. We do this with what we call our business workflow views, which allows you to roll an entire application and all of its component parts into a single percentage score that's very easy to understand. We can also share this data in a number of different forms, depending on what works for the environment. So things like APIs, common share pages or intranet pages, unauthenticated status pages, and information radiators. An information radiator is really just a system designed to display important status information in a public area. So for example, a monitor on the wall of a hallway that everybody walks through. The team can display application views or more technical ones depending on the audience and what we exactly need to show them and what they're expecting to see. It also allows us to keep the teams in sync, not just for status data, but I can also include useful operational metrics if I want to on these pages, like things like response time or transaction velocity, or number of procedures being transmitted. I can also use information radiators to demonstrate our core values. So, for example, that my team has nothing to hide from visitors, customers, stakeholders, and we have nothing to hide from ourselves. We acknowledge and confront problems as they occur. And that really works towards that building that trust that we talked about. Now, I'd also like to share a few best practices that we've gathered from working with some very large and successful healthcare operations that have a direct bearing on how successful your overall monitoring implementation is going to be. One of the best practices that you can adopt is to centralize all monitoring through the command center. This not only reduces the admin and training overhead, as well as your maintenance spend, but it has three major advantages as well. First, the command center is able to quickly determine whether a problem in one area is affecting other areas. So for example, if a server goes down and several applications suddenly go red at the same time, the command center staff is going to know which support teams to notify first. A team that's monitoring its own area only may not be aware of the nature of the failure and is going to waste valuable time diagnosing the problem. So for example, a problem in storage might cause the application people to see a slow response time, and if they're monitoring separately, they're going to spend a lot of time trying to figure out what's causing their application to slow down, when really with a centralized view, we'd know that the storage problem is what precipitated that. The second big advantage is transparency. So teams that are being watched by others tend to run better with fewer problems, because when something breaks, they want to find a permanent solution so the same issue doesn't happen again. If everyone is sharing a single source of truth, there's a lot less time wasted finger pointing between teams, and this is going to reduce the time to repair, and that directly translates into reducing costs. The third is standardization. And this really means having a consistent, repeatable methodology for what should be getting monitored, how to monitor it, and making sure that that is applied consistently and correctly across all of the different devices and applications, even as the environment is constantly changing and growing. Our approach is to use things like templates and auto configuration rules to allow you to fully automate the best practices of monitoring so nothing ever gets missed. That way, we can detect new devices as they come online, add all the monitoring with the settings all predefined, so we're never depending on an unreliable manual process or a checklist where people have to manually enter things into the monitoring system so that they get watched correctly. You should also try to avoid letting individual teams utilize standalone products if there's any alternative. It's okay to let them use in-depth diagnostic tools, for example, if they require that for their team. But for the general monitoring, you should avoid it, as it's going to add training burden and can lead to finger pointing issues. Like, your tool shows the application isn't responding, but our tool says it's fine. Now that slows down recovery efforts and ultimately costs you money in the form of extended recovery times and repeated failures. Also, every alert that the command center receives needs to be acted upon. So if an alert isn't going to generate a response, eliminate it and instead use scheduled and automated reports to maintain that visibility without disrupting the team in real time. And if too many alerts are generated, you can use tools like our template baseline report or incident history logs to identify the sources of those alerts and correct them so that incidents and alerts are only triggered when there's an actionable thing that needs to be done. You can also automate the initial response to alerts, which you should do wherever possible. So things like restarting services or rebooting servers, or even logging into systems to dump diagnostic information when a problem happens. This reduces the manual interventions that have to be done, and it can go a long way towards speeding up recovery times. Now, I know we just said it, but we're going to say it again because ignoring alerts is a surefire way of getting into trouble. At some point, a mistake is going to be made. Somebody will ignore the wrong alert. And this leads to a condition we call dashboard measles, where the screens are just covered in red spots. The monitoring screen that's covered with alerts makes it very easy to miss a new critical alert that needs to be acted upon. So alerts should be acted upon and acknowledged or corrected as soon as possible. It should not be acceptable to let alerts sit in the queue until the support team's regular work hours. So if the condition is acceptable when it happens during off hours, the alert should only be generated when it is not acceptable and when someone is available to work on the problem. You can largely avoid this problem altogether by making sure that non-actionable alerts are never even seen. You could still report after the fact on adverse or unusual conditions for proactive investigations. But you don't want to get monitoring tunnel vision. So we want to make sure that we're sharing the information outside the team to make sure everyone can use it. And we want to monitor, for example, from where the users are located. So our platform allows you to integrate your own private remote data collectors, either on site or in the cloud. And you can also leverage our network of remote reflector systems around the world that allow you to monitor your public facing sites from anywhere, even if your monitoring system is on premise. And possibly most importantly, don't let support teams perform their own monitoring exclusively. It's okay if they want a view of what the command center sees, but it is not okay to let them perform monitoring instead of the command center. Departments and teams that perform their own monitoring with no oversight tend to hide their dirty laundry. They also tend to apply temporary fixes. So as a result, you will end up with more outages, longer outage times, and a higher percentage of recurring outages. And because there's no oversight, senior management is often unaware of the number or scope of the outages, and they can't direct the resources where they're needed to truly improve the performance for the end users. Now, I'd like to take just a moment to talk about who we are for those of us who haven't worked with us before. Netreo is in the middle of our 20th year, and we've been profitable since year one with a proven track record in both public and private enterprise and a customer retention rate of over 98%. We won Monitoring Product of the Year from Network Computing UK 4 years running, and we made the Inc. list of fastest growing companies for the last 3 years as well. In 2018, after many successful years of being internally funded, we did a private equity transaction to gain additional working capital and resources, as well as access to some very experienced business experts, allowing us to grow even faster. Now I'd like to take a few minutes to address any questions that you have, so please enter them into the GoToWebinar interface if you haven't done that already. I'm also going to launch a poll, so if you'd like us to follow up with specific information or to discuss your unique environment, you can let us know that way and we'll get in touch with you privately. Okay, here, let me just pull up the questions. Okay, so first question, how is Netreo deployed? Is it a cloud-based system or what? So most of our healthcare clients use on-premise appliances to keep all the data local and under direct control. The appliance is designed to be completely self-contained, so there's minimal administrative overhead, there's no OS maintenance, and no external databases to license or secure. However, our solution is designed to be uniquely flexible, so you can implement it as a SaaS solution if that works better for you, or even deploy it in your own private cloud or VPC. You can also deploy remote collector appliances wherever you need, so if you have segmented network access or isolated DMZs, there's an easy solution to collect that data as well. Next question. How is OmniCenter licensed? So we license very simply just by number of devices. So every device counts as a single type of device, whether it's a server with 50 hard drives or a storage array or a stack of switches that's monitored as a single logical entity. Every logical operating system effectively counts as one device license, which makes it very easy and streamlined to be able to figure out exactly what you need in terms of licensing and then to scale up or down as needed. A single appliance can scale to up to 25,000 devices under monitoring, and that includes all of the different variables that we're monitoring on those devices per process utilization, all the way down to drive storage, IO, all those different kind of metrics. We don't charge by the metric, we don't charge by the monitor. And then there's individual capabilities you can add, like there's a healthcare pack that specifically adds in all of the DICOM and HL7 monitors, as well as the ability to consolidate those applications together and look at the big picture we talked about. Okay, well, thanks for joining us today. I really hope you've learned some useful tips and keys to improving your imaging modality and PACS environment monitoring. And as always, if you have any additional questions, please feel free to contact us at info@netreo.com, and we'll be sure to get back to you right away. Thanks, and have a great rest of your day, everyone.